So this is 7.3c, trigonometry, the law of cosines. We're on example 3. Now in example 3 they give us 3 lengths of the triangle, and now we've got to go ahead and find the 3 angles because they gave us all 3 lengths, side, side, side. So we're just going to pick one of the formulas. C squared equals a squared plus b squared minus 2ab cosine of c. Now in the formula they only give us one angle, this right here. So we're going to look for that angle, so that means we have to get rid of everything else. So let's go ahead and rewrite this. C squared minus a squared minus b squared equals negative 2ab cosine c. So I moved this over. Now let's move this over. And that goes away. Alright, so at this point let's plug our numbers in. We've got 21.1 squared minus a, which is 9.47 squared, minus b squared 15.9 over negative 2 times a 9.47 times b 15.9, and that equals your cosine of c. So we do all the math for this, and we should get negative 0.3411-ish, and that would be equal to my cosine of c. Alright, so in order to find the angle, you're going to have to take the arc cosine. Okay? So I'm sorry, wrong number. Of negative 0.3411. So you're going to do that, and that will give you your angle C, which is going to be around 110 degrees. So C will be 110. And then now you've got to find A or B. So you're going to use either the law of sines or the law of cosines, which I'm not going to do because you should already know how to do that. It should be pretty simple to find one of the other angles. So find angle A or find angle B. So now that you have one of your angles here, so now you have 3 sides and an angle. Actually you have 2 sides A and B and your included angle. So you have side angle side, so you could use the law of cosines again, and you could also use the law of sines. Doesn't really matter, but find out what one of the other angles are, and when you have 2 of the angles it's obvious what the third angle is because of 180 minus the other 2. So that is example 3. Let's look at example 4 and then we'll get on with Heron's formula. So example number 4, whenever you're building a house you have what are called trusses. These here are trusses. It's what holds the roof up. Now this is the simplest kind of a truss, a triangle, and here it is right here. And they put these here just so they're a little bit more stable. They're just little pieces of plywood that they stick there. We're going to ignore those. So we've got 9 foot, 6 foot, and 11 foot. And what does it ask us to find? It asks us to find angle B. Okay? So we're going to use the law of cosines with the B portion. Because this formula is the only one that has the angle B in it. So we're going to use that one. So we're going to go ahead and rearrange everything so that we have the cosine of B. So we'll have B squared minus A squared minus C squared by subtracting both sides by that. And then we're going to divide by that. And that will be the cosine of B. Okay. Then we can start putting numbers in there. So we can put the length of B and the length of A and the length of C in there, and we end up getting, I'm just going to assume you can do all that because that's just pretty simple math. Okay, we're going to get approximately again. It's not going to be full on exact. And then we're going to take the cosine of -1 of 0.8384, and that will give us our angle B, and we find out that it's 33 degrees. Okay? So, 4 possible cases can occur when solving an oblique triangle as summarized in the following table. This is bottom of page 296. In all 4 cases, it is assumed that the given information actually produces a triangle. So we're assuming that this is a triangle. All right, so one of your cases, you're given one side and 2 angles. Let's go ahead and have fun here. So you're given one length of one side, and you're also given 2 angles. So you're given that bit of information. Side angle angle or angle side angle. So anyway, one side and 2 angles. And in order to solve this is find the remaining angles using the formula a plus b plus c equals 180, and then find the remaining sides using the law of sines. Okay, so what they're doing is they're giving you different options that they may give you. And then on the right-hand column, they're telling you, okay, so given these options, this is how you solve it. So for this particular one I have there, if you're given one side and 2 angles, it's easy to find this angle by subtracting from 180. And we can also find this side and this side by using the law of sines. So it's just giving us some simple ways to solve these. So case 2, 2 sides and 1, alright, let's get the triangle on here. 2 sides and 1 angle not between them. So there's 2 sides they give us, and there's the angle not between them. Okay, so they give you that. So this is an ambiguous case, so it could be that there are no triangles, or that there's 1 triangle, or that there's 2. So find an angle using the law of sines, find the remaining angle using the a plus b plus c equals 180, and then find the remaining side using the law of sines. Okay? Case 3. Another triangle. 2 sides and the included angle are known. So they give us that one. Here are the steps. Find the third side using the law of cosines. Find the smaller of the 2 remaining angles using the law of sines. Find the remaining angle using the a plus b plus c equals 180. And then case 4, if we know all 3 sides of the angle, find the largest angle using the law of cosines. And remember, the largest angle is going to be the angle across from the longest side. So you're going to do that first using the law of cosines. Find either of the other angles. We're going to find this angle or this angle using the law of sines. And then find the remaining angle using the a plus b plus c equals 180. Okay, so those are just some suggestions. You don't have to use those. Those are just some suggestions in order to quickly and efficiently be able to find or be able to solve the triangle. Okay, so that's it for this video, and we'll get Heron's formula on the next video.